Hello friends, good day. Today we will discuss for India's Chandrayaan-3 and brief about past moon mission. We will discuss about Chandrayaan-3 from making, launch, its followed path to landing on moon surface. Let's have a successful journey. Moon landing. A moon landing or lunar landing is the arrival of a spacecraft on the surface of the moon. Chandrayaan-3 is the third moon mission by India's space agency ISRO. The goal is to place a lander and rover on the lunar surface and operate them for roughly 1 lunar day, or 14 Earth days. The small rover, which weighs just 26 kilograms, will fly to the moon inside the lander. Chandrayaan-3 does not include an orbiter, although the propulsion module that will carry the lander to lunar orbit. Let's discuss a brief history of various moon landing success. 6 countries had made attempted to land on moon. For country, USA, USSR, China, and India have successful stories. But Israel and Japan failed to land on moon. Now let us know about their moon landing stories. A moon landing or lunar landing is the arrival of a spacecraft on the surface of the moon. This includes both crewed and robotic missions. The first human-made object to touch the moon was the Soviet Union's Luna 2 on September 13, 1959. The United States Apollo 11 was the first crewed mission to land on the moon on July 20, 1969. There were 6 crewed U.S. landings between 1969 and 1972, and numerous uncrewed landings, with no soft landings happening between August 22, 1976 and December 14, 2013. The United States is the only country to have successfully conducted crewed missions to the moon, with the last departing the lunar surface in December 1972. All soft landings took place on the near side of the moon until January 3, 2019, when the Chinese Chandrayaan 4 spacecraft made the first landing on the far side of the moon. The Soviet Union achieved the first uncrewed lunar soil sample return with the Luna 16 probe on September 24, 1970. This was followed by Luna 20 and Luna 24 in 1972 and 1976, respectively. The Chinese lunar orbiter Chandrayaan-1 executed a controlled crash onto the surface of the moon on March 1, 2009. The rover mission Chandrayaan-3 soft landed on December 14, 2013, as did its successor, Chandrayaan-4, on January 3, 2019. All crewed and uncrewed soft landings had taken place on the near side of the moon until January 3, 2019, when the Chinese Chandrayaan 4 spacecraft made the first landing on the far side of the moon. The Indian Space Research Organisation, ISRO, performed a controlled crash impact with its Moon Impact Probe, MIP, on November 14, 2008. The MIP was an ejected probe from the Indian Chandrayaan-1 lunar orbiter and performed remote sensing experiments during its descent to the lunar surface. On February 22, 2019, Israeli private space agency SpaceX launched their spacecraft Beresheet on a Falcon 9 from Cape Canaveral, Florida, with the intention of achieving a soft landing. SpaceX lost contact with the spacecraft shortly before landing on April 11, 2019. Indian Space Research Organisation launched Chandrayaan-2 on July 22, 2019, with landing scheduled on September 6, 2019. However, at an altitude of 2.1 kilometers from the moon a few minutes before soft landing, the lander lost contact with the control room. Private Japanese company Space Hakuto, ARVY Mission 1, failed to land on April 25, 2023. The Indian Space Research Organisation, ISRO, released the first images of the moon as viewed by Chandrayaan-3. These visuals offer a unique perspective of the lunar surface, marking a significant milestone in India's space exploration journey. After covering about 2/3 of the distance to the moon, it was successfully inserted into lunar orbit on August 5, 2023. A day after this significant achievement, ISRO released the visuals. The spacecraft was launched on July 14, 2023, from the Satish Dhawan Space Center in Andhra Pradesh's Sriharikota. This mission underscores ISRO's commitment to advancing our understanding of the moon and the broader universe. Indian Chandrayaan-3 going to be a success. What is Moon's South Pole region? It essentially contains ice and may be rich in other resources. The South Pole's frozen water may date back billions of years and has been untainted by the sun's radiation or the geological processes, according to NASA. The craters are cold-trapped that contain a fossil record of hydrogen, water ice, and other volatiles dating from the early solar system. The matter trapped in the southern lunar region wouldn't have witnessed much change over the years and could thereby hold clues to early life. Scientists have always been fascinated by the southern lunar pole. What is the difference between Chandrayaan-3 of India and Lunar 25 of Russia? India's Chandrayaan-3 mission and Russia's Luna-25 mission are two ambitious lunar missions set to explore the largely uncharted south polar region of the Moon. The Luna-25 mission is expected to operate on the lunar surface for about a year, much longer than Chandrayaan-3's planned 2-week operational period. Despite their shared objectives, these missions differ significantly in their strategies, timelines, and research goals. While Chandrayaan-3 is focused on demonstrating a safe landing and conducting scientific experiments at the site, Luna-25 aims to analyze the lunar soil and exosphere. Now, do you know the purpose of India's Chandrayaan-3 on the surface of the Moon? ISRO has made a lot of improvements in Vikram lander and rover as compared to Chandrayaan-2. As the lander was designed to withstand a failed landing attempt through a number of complex software simulations. The rover is a 6-wheeled design, weighs 26 kilograms, and has a range of 500 meters. The dimensions are 917 millimeters by 750 millimeters by 397 millimeters. The Chandrayaan-3 rover is expected to make several important scientific discoveries, including composition of the lunar surface, presence of water ice in the lunar soil, history of lunar impact, evolution of the Moon's atmosphere. The rover carries two payloads, the laser-induced breakdown spectroscope, LIBS, to determine the chemical and mineralogical composition of the surface. The alpha particle X-ray spectrometer, APXS, determines the elemental composition of the surface. ISRO specifically mentioned magnesium, aluminum, silicon, potassium, calcium, titanium, and iron as elements the rover would hunt for. The lander has 4 payloads: radio anatomy of Moon-bound hypersensitive ionosphere and atmosphere, measuring how the local gas and plasma environment changes over time. Chandra's surface thermophysical experiment studies the thermal properties of the surface. The instrument for lunar seismic activity, ILSA, measures seismic activity at the landing site to image the subsurface crust and mantle. Laser retroreflector array, LRA, a retroreflector supplied by NASA that allows lunar studies. Laser ranging is the process of zapping a reflector, a laser measuring the time it takes for the signal to return. NASA still measures the distance to the Moon using retroreflectors left over from the Apollo program. Vikram will land in the South Pole region, a region that has not been explored as much as the equatorial region. Let you know the journey of Chandrayaan-3 from making it to the surface of the Moon? The mission began on July 14 with the launch of India's LVM-3 rocket, the country's heavy lift vehicle capable of placing approximately 8 metric tons into low Earth orbit. For comparison, the SpaceX Falcon 9 rocket can lift approximately 23 metric tons into low Earth orbit. It will consist of 3 stages: Earth orbit maneuver, translunar injection, and lunar orbit maneuver. The landing site chosen for Vikram lander in this mission is 4 kilometers by 2 kilometers as compared to the previous mission. Soft landing speed has been increased from 2 meters per second to 3 meters. The LVM-3 spacecraft and an attached propulsion module will orbit the planet at an apogee, or high point, of approximately 36,500 km. The propulsion module will raise its orbit 5 times before being transferred to lunar orbit. Each time the spacecraft approaches the perigee, the engines will be fired to increase its speed. As the journey continues, the module eventually reaches the escape velocity needed to break free from Earth's gravity and goes into the orbit of the Moon. Chandrayaan-3 will revolve around the Earth 5 times, each time increasing its distance from the Earth. Then, after completing the 5th maneuver, it starts moving toward the Moon. This stage is the translunar injection stage. Similar to maneuvers around the Earth, the module orbits the Moon 4 times. On the Moon orbit, the propulsion module will continue to reduce the speed of Chandrayaan-3, i.e. Vikram lander. Also due to the gravity of the Moon, Vikram lander reached the 100-kilometer circular orbit of the Moon. Here, the Vikram lander separates from the propulsion module and changes its orbit, bringing the Vikram lander 30 kilometers closer to the Moon. This means that it will be 100 kilometers farthest from the Moon and 30 kilometers closest. Then, the lander starts the process of a soft landing. At an altitude of about 30 kilometers, the lander starts using its thrusters to descend to the surface. This is the powered braking phase. There, both the vehicle propulsion module and the Vikram lander will separate. Then the Vikram lander exits that orbit and the lander reorients itself to 90 degrees for a safe landing. At an altitude of about 100 m, the lander scans the surface for obstacles. If there is no obstruction, it begins a slow descent and fires its thrusters until touchdown, and lands in the south polar region of the Moon. While landing on the Moon, the lander came vertically towards the lunar surface at 2 meters per second and horizontally, it was less than 0.5 meters per second. At an altitude of about 100 m, the lander scans the surface for obstacles. If there is no obstruction, it begins a slow descent and fires its thrusters until touchdown. And lands in the south polar region of the moon. While landing on the moon, the lander came vertically towards the lunar surface at 2 meters per second and horizontally, it was less than 0.5 meters per second. However, this is not an easy task. Soft landing of the lunar module means going down to zero at a very high speed of more than 6,000 kilometers per hour. Just hitting the brakes won't do it. Even after slowing down, the problem of lunar dust persists. While touching down, the lander's thrusters blast lunar dust off the surface at high speed. This may obscure the camera lens and result in inaccurate readings. Immediately after landing, a side panel of the Chandrayaan-3 lander opens to form a ramp for the rover. The rover comes out of the belly of the lander, goes down the ramp and starts exploring the lunar atmosphere. The solar-powered lander and rover will remain active for about 2 weeks to study their surroundings. India's next great mission Sun mission. ADITYA L1 would be the first space-based Indian observatory to study the Sun. According to the ISRO, the spacecraft will be placed in a halo orbit around the Lagrange point 1, L1, of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. A satellite placed in the halo orbit around the L1 point enjoys the major advantage of having a continuous view of the Sun without any occultation per eclipses. This will enhance the observation of solar activity and its effect on space weather in real time. The spacecraft carries 7 payloads to observe the photosphere, chromosphere, and the outermost layers of the Sun, the corona, using electromagnetic and particle and magnetic field detectors. From the special vantage point L1, 4 payloads would directly view the Sun. The other 3 payloads are to carry out in situ studies of particles and fields at the Lagrange point, L1, providing important scientific information of the propagational effect of solar dynamics in the interplanetary medium. ADITYA L1's payloads are expected to provide crucial information for understanding the problem of coronal heating, coronal mass ejection, pre-flare and flare activities and their characteristics, the dynamics of space weather, and the propagation of particles and fields. The ADITYA L1 mission will be launched by Polar Satellite Launch Vehicle, PSLV. Thanks for watching. Friends, please subscribe to the channel.